Welcome everyone to another session regarding renewable energy power system. Today, we're going to address an important and a critical topic. The reason behind this presentation, I received large number of concerns, emails, messages from my colleagues in the Middle East, especially Lebanon. They're asking about lightning requirement, lightning protection for their rooftop installed solar system. Lightning could be the source that can cause a damage not only to your PV system, also to your entire building. That's why it must be considered. So during today's presentation, I would like to highlight why rooftop lightning protection system is a must. هي شغلة ضرورية مش من الكماليات من الضروريات to ensure safe environment not only for your system مش بس على الطاقة الشمسية for your building. Lightning protection has multiple phases. Lightning protection doesn't mean you have to install rod, install earth grid. First, you need to do an assessment. The assessment determines, do you require a lightning system design or you don't require it? What type of design do you require? In this presentation, we're going to assume that you did your assessment and your assessment shows that you do need a lightning design, and we'll show you a couple of stuff that you need to consider. We're going to talk about lightning for Lebanon and the Middle East, lightning design for rooftop PV system, lightning shield, lightning design layout and products based on what I recommend, and then we will have a quick conclusion. Now, why rooftop? Why? The lightning energy that can be discharged, it could be very high. Could be very high to a limit that can cause a damage, can cause a destructive steps that could cause a major damage to your PV system and also to your buildings. So you have to be very, very critical, guys. According to the current research, installation of a PV solar system will not increase the risk of lightning strike. يعني نحن لما بنركب طاقة شمسية على ظهر البناية على ظهر البيت مش معناتها we're gonna attract مش معناتها بدنا نجيب lightning strike أو صواعق. No, it doesn't. However, because your solar system now integrated part of your building electric network, it has the potential for substantial interference with the building system. Using the newly installed PV system, because your PV system is integrated. نحن بس نركب طاقة شمسية، هيدي الطاقة الشمسية وصلت، صار عندنا نحن وصلة بين البناية اللي هو الالكتريك سيستم اللي هو فيه الكوميونيكيشن تيليكوميونيكيشن كمان مع الروف where the lightning strike hit. That's why it's a must. It's a critical and vital to consider the risk resulting of a lightning strike when installing solar system. We must. بالأخص, if you are located in an area where there's a high ground flash density for lightning. Now, damage due to lightning strike, it will cause this, and if your surge arrestor or your surge protection device, the SPD, does not work properly, this energy will be transferred to the electric system in your building. That's why you must install it. And before we continue, I would like to highlight one important element, that the lighting system for a PV farm or for a photovoltaic that located in a farm for water irrigations is different than this. Because over there, they're located on their own. You will see when we go further. Now, why rooftop lighting is a must? We spoke about all these items. I want to show you for Lebanon and the Middle East. According to the gathered data, المعلومات الموجودة, it shows that the lightning density for Lebanon is the highest among the region. Look, Lebanon has 3.7 events per square kilometer per year. إذا نحن نطلع على الريجن من سوريا لبالستين لجوردن لإراق Saudi Arabia, you will see that their event is way lower, 1.6 for Syria, Palestine 1.1, Jordan 1.8, Iraq 2.9, Saudi Arabia 3.3. Now you have Turkey and Greece, and Cyprus, they have a higher. But for us in Lebanon, every 1 kilometer, you will have 3.7 event every year for a lightning. That's why you should consider it. Imagine you have a building worth millions of dollars. You install a solar system, and suddenly, not this year, next year, year after, 1 year a lightning hit, you don't have a proper protection, you not only burn your system, you could have a high chance to damage your building as well. It's worth noting, guys, it's worth noting that Vaisala, during this assessment period, they collected 10 billion lightning events. They collected 10 billion lightning events were detected with their operated lightning detection network worldwide, in the state, in the region, and everywhere. So these data can be considered, should look after with cautious. It's not just data. I really need to think, do I have to do it or no? I consider the consequences. If I don't do lightning design, what are the consequences? Damaging my photovoltaic, burning my inverter, or does it have the extent to go all the way down to damage my building? Now, when it comes to rooftop, there is a few elements that I must consider. بس تجي على البناية أو على البيت, like I said, it's a different requirement than PV farm, or it's actually there's additional requirement. إنه هون عندنا building. You have a building, عندك البناية, البيت السكن فيه. You have to protect the house as well, not only your system. You have adequate lighting, shield protection. لازم يكون أول شيء عندنا proper shielding protection if it's required. We must have adequate surge protection device for the DC and AC. So for the DC and for the AC as well. You should have adequate cable routing and earthing of a PV system. And one of the most important elements is how do you select your SPD? To select the SPD, there is a multiple item that you have to consider. It's not only go to the shop and collect. No, you must consider which one is the most suitable for you. Now, when it comes to lightning shield, we discussed lightning shield, surge protection, cable routing and earthing, and adequate selection of SPD, surge protection device. We want to start with the first one, to discuss the first one, which is shield. When I come to shield, you have under IEEE and IEC standard, I can distinguish two methods. One of them with the angle, one of them with the rolling sphere. This, we want to discuss the rolling sphere method. Now, what does the rolling sphere method mean is, if I need to protect this building or this compound, I need, depending on the strike radius, I need to put two masks. The sphere will touch the two masks before it touches my protected structure. يعني أنا بدي أحمي البناية أو السيستم يلي عندي من اللايتنينج will need to design. لازم نحن يكون عندنا two mast, two shield. This two shield will depend on the details of your structure need to be protected and on your strike radius. You have to be careful as well for the photovoltaic. If you are using a big mast, and usually in your building you don't have big mast, but if you have a big building and you have a big system and you want to use a big mast, do not shade your PV system when it comes to the shield. Make sure the shadow line is considered. For lightning shield design, according to IEEE standard, I have these four equations are being cited. S is your strike distance, which is I can consider my radius for my sphere. I is a current, lightning current magnitude. Lightning current magnitude. Now, for lightning shield, countries set standard. So for example, if I go to the Australia-New Zealand 1768 lightning protection, they set 4 protection levels. Every protection level, they determine the interception current magnitude in kiloamps and the sphere radius. And the sphere radius. And you will see that this is similar to the IEC standard as well. So now we started with the shield design by designing either the angle or the rolling sphere. In this one, we will discuss the rolling sphere method. So now, if you have a level 1 protection, level protection 1, you have a 20 meters, which is you have 2.9 kiloamps. If you have level 4, you have 15.7 kiloamps, and the radius is 60 meters. Now, the mast details depend on, as we spoke before, on the object height, object separation to mast. يعني المast, how far has it to be? يعني هي المast, is it on the structure or 10 meters away from the structure? The strike radius, and that's how we can design it. If I know the height of my object that need to be protected, I can design one mast based on these equations. If I do a little bit algorithm, I can come up with this equation. This equation determines the height of my mast based on the height of your object and the separation. Remember, the separation has to go to the end, to the edge of your protected system. If I want to design 2 masts, not one, and I want the 2 mast separation have a distance m, I can also calculate the h based on these separations. So عندي solar system أو بناية أنا بدي أحط, I want to put the 2 mast, these 2 mast, I can calculate the h, the height of the mast based on the strike, and again the strike distance depend on your level of protection. So I can use this information depending on what standard am I applying, what level am I applying, level 1, level 2, level 3, level 4. For example, in Australia you can use level 3. In Germany they can use level 3. If you want to use level 3 or level 2 or level 1, there is, under IEC and under Australian standard, there is a risk assessment that you can determine which level are you located in. Now, what's the relation between lightning and surge voltage? Before we go into the surge protection, I need to tell you that when the lightning hit, it will introduce a surge voltage, which are induced on the electric wires. And this induced into the electric wire causes a very massive force or energy that goes into the wire. Depending, if it goes to your appliances, it will damage it. If you have a protection that diverts this energy into a designed earthing system, that will be perfect. So the SPD, the surge protection device that installed on the DC side, also on the AC side, will help in protecting the system from the lightning surge voltage. So what's its role? As soon as it will detect the surge, it will open up and discharge the energy away from your system and protect it. In many standards, they call surge voltage as a destructive voltage due to its severity. It can cause destruction, guys, for your system. It causes destructions. Now, many standards worldwide request an installation of an SPD unless a risk assessment is completed and showing otherwise. So I need to consider the risk assessment. If the risk assessment comes back and said there is no need for an SPD, I don't have to worry about an SPD or lightning system design. The other item that we discussed is cable routing and earthing. Guys, I need to make sure if I don't have a proper earthing system and I run cable in loops, so I get 20 cable running in loops to create a bigger conductor, larger conductor loop, I'll increase my risk. The designer and installer must pay attention to the DC circuit, especially when they're combining multiple strings together. Sometimes, depending on your system, you might have to put 10 strings, so you have 10 cables. Put them together, in reality, you're making big cable. Same, data line must not be routed over several strings because you're adding more and more. Now, to avoid all this issue, DC and AC and data line can be or must be routed with equipotential bonding conductor. Equipotential bonding conductor along the entire route. This presentation, it's not prepared, or the purpose of this presentation is not to deliver the earthing system requirement. On the channel, there are, I think, about 6 or 7 videos talk about earthing system. You can go and check what's the equipotential. Now, this is for the cabling. For the earthing system, we install a panel on a conductive metallic structure most of the time. And these conductive structures, you put together, the frame, the aluminum frame, which is also conductive, you put it together with your steel structure that's bolted or supported to your buildings. So there are 2 types of earthing and lightning layout. You need, our preferred system, the first method is to separate the lightning system from your PV. 2 types. Number 1, I need to provide an adequate separations, if possible. Now, based on my site visit to Beirut, I inspected many places. It's almost impossible to maintain separation under level 3 or level 4 protection. That's why we must put a combined system. Unfortunately, we must put a combined system. Now, what I need you to focus, guys, if you have a separate lightning and earthing system of UPV, you can use a 6 mil. As soon I have a combined system, I need to go to a bigger size because the lightning current, it's very huge. I know it's in microsecond, but still. So pay attention on this element. Now, so what determines if I go to this system or that system is my separation S, is my distance separations. Before we go into assisted separations, I need to tell you guys that under a flush over, if your lightning flush over to your buildings because you don't have adequate separations, could cause a potential harm and set your building on fire. Okay? So please consider this. That's why if I cannot maintain the spacing under the IEC, IEEE, any other standard, I better put it as a combined system. And under this presentation, we utilize separation requirement under IEC standard, which is lightning protection system. Now, so if I have a solar system, I need to have a lightning system. My lightning protection is have a minimum a separation S, which is based on IEC standard. If you're doing level 1, it's 10 ampere. Level 2, 10 meters. Level 3, 15 meters. Level 4, 20 meters. My recommendation to go to 15 meters for separation. Now, most of the installation that I've seen, it's very hard to maintain 15 meters, 15 meters, 15 meters, 15 meters the system. It's very hard because they put it on the edge. And put the down rod. Now, even, pay attention, even if you have a separation S, you still have to put your SPD on your earthing system for your PV. Because if there's a flush over, the probability, it's not possible to have 100%. That's why you must have this as well. We're going to talk about the SPD soon. Okay, so this is part of the earthing system. Now, if you cannot maintain separation, I bond it together. I bond the system with your lightning system, and I take it down as a common, and I will have my surge protection system. I hope that's clear to everyone. Now, how do I select an SPD? Many people will go pick up any surge protection device. No. For us, we need to distinguish between a normal DC and a PV system. We need to distinguish between normal PV and system. Pay attention. The blue line represents your voltage and a current for a PV. Your red line represents your normal DC. So it's clear the normal DC is different. The characteristic of your PV is different. That's why you must pick up a device that meets the characteristic of your PV. The VI characteristic forces the requirement of a larger switch. Look, see, look, this voltage level or the current, look in here. See, it's different. It forces the requirement of a larger switch fuse, also SPD that can adapt to this curve relationship between voltage and current. Under normal DC, this is your relationship. It's a linear. Now, it's a curve. It's not linear. That's why I need to make sure I have my SPD comply with this curve relationship. The selection of the SPD depends on, pay attention, number of down conductors. If I go back depending on the number of down conductors. In this case, I have 1, 2, maybe 3, 4. So it depends on the number of conductors and class level of protection system. Is it 1, 2, 3, or 4? It's very important. And as soon as you determine the class level, you can go to a specialized SPD and tell them I need a SPD suitable for level 2, and they usually distinguish between two types of drop conductors. One of them is bigger than 4 conductors or less than 4 conductors, that goes down. Down conductors. Okay? Now, adequate cable routing and earthing of a PV system. When I go back to this element, when I put an SPD in here, I need to check for a lot of items. Number one, if I have 2 MPPT, do I have to take the MPPT down, each one separately, or do I combine the MPPT together and then I put one SPD? So you have to be very, very careful about this. Depending on your system, how critical it is, I can put separate SPD or combine SPD. Okay, guys? The drop conductors, these drop conductors is different than these 3. When I have a drop conductors, more drop conductors into the ground, I have a bigger earthing system. The bigger earthing system, I have a lower resistance. A lower resistance, I have a lower surge voltage. Lower surge voltage will lead me to a lower voltage required for my SPD. There is a YouTube video about lightning, how to calculate the nominal voltage based on this system. So the resistance value of the ground play an important role. The SPD selection, the VNI curve, is no linear. So, we spoke about this. My recommendation, I recommend the following for you guys. If your analysis support or required a lightning system, I recommend to put an SPD. Number 1, you put a lightning shield. Number 2, you put an SPD on the AC and DC side. Because the AC side, the lightning could be transferred to the AC side from the grid. You need to use adequate or proper lightning mast. Use proper SPD, and also, depending on the severity of your system or the complexity, I can put a sensor that will count how many times it will trip for future analysis and future design advancement of your system. To conclude, lightning assessment design is a must for all rooftop system installation, especially if I'm talking about the Middle East. Lebanon has the highest record of a lightning event per square meter per year, which is 3.7 in comparison to the neighbor's country. Adequate consideration must be taken during the design if the building has an external lighting system. If the building has an external lighting system, I need to put a separate one. I need to put separation. If I cannot put separation between my PV and the lighting, I have to combine them together. Okay? And my recommendation is to keep them separate if you can. Because that way you reduce the burden on your surge potential device. Choose the correct or the adequate SPD for your system and your earthing system must meet the standard requirement. My recommendation to you, use 10 ohm or less for your earth grid. Use 10 ohm or less, and that comply with IEEE, IEC, and Australian standard. Now, one more recommendation for you. When you go ahead and do a lighting design, you have to consider the surrounding structure. You might have a building, I know it's 20 meters away from you or 15 meters, but it's higher than you. This will provide you with a massive, strong shield. So, step number one, when you want to install a solar system, number one, engage with a professional person that knows how to do lightning performance assessment, risk assessment. Based on the risk assessment, will determine the level of protection required. If it's required, it might say there's no requirement, only install a SPD, there's nothing required. Number two, please, when you buy your equipment, your SPD, your equipment, make sure it's suitable for PV. AC and a normal DC is different than a PV because of the curve. And that's it for today. Thank you for listening, and we'll see you next time.